students, welcome to video lecture on dynamics of machinery. In the today's lecture, we'll discuss about numericals on free undamped single degree of freedom system. So let us start with the first numerical on the same topic. Find the natural frequency of a simple pendulum by free body diagram method and energy method. Neglect the mass of a rod. So simple pendulum is given like this one. Okay, so length of this one string with us L. Okay, so mass of this heavy bob with us M. Okay, this is the case of simple pendulum. Our target is to get the natural frequency for the same. Okay, so first you have to solve this problem by using free body diagram method and second by energy method. So let's start this problem by first method, that is free body diagram method. Okay, so first of all you have to draw the free body diagram for the given system. For that, just give the displacement for this system and say when I stretch this one walk towards one side like this one, okay, and release it, this will start oscillate about this one mean position. Okay, so the displacement takes place by small angle theta. Now whatever the weight of this bob, that will adds in downward direction. Okay, so what's about this one? This component is nothing but the mg cos of theta. Okay, so as this angle theta and this one is same, so this component must be mg cos of theta, and second one mg sin of theta. Okay, now once the free body diagram with us, the next task is very easy. Apply the Newton's second law of motion for this case. Now from Newton's law of motion, so already I have seen this Newton's second law of motion for formulation of differential equation. So what's about that Newton's second law of motion? Accelerating force equals to summation of external forces. Now for that, it is very important to know what's about the accelerating forces available in the system. When I pull this one, okay, this one simple pendulum walk towards one side. Okay, so in the direction of motion of this bob, so what's about this one? This is nothing but the accelerating force. Okay, and what's about the next one? So mg sin theta, this component pull this system towards one direction, and this component restores its position, okay, at the main position. Okay, so this is nothing but the restoring force or restoring torque. Okay, so this force mg sin theta is nothing but the force component, and this distance, so L length with us for this pendulum, so distance multiplied by force is nothing but the restoring torque. So this is nothing but the accelerating force, right? This accelerating force towards the one side. Okay, so as per notations we have discussed in previous lecture, for the anti-clockwise movement you have to consider the positive sign, and for the clockwise movement you have to consider the negative sign. So here this turns about this point in anti-clockwise direction, so consider the positive sign for this one, and restoring torque. Okay, this will actually, this one restoring force turns about this point in clockwise direction, so give the minus sign for this one. So what's about its magnitude? mg sin of theta multiplied by, so what's about the distance, the length for this pendulum with us L. Okay, now as the value for sin theta here very small, theta is small, so you can say sin theta for the smaller angle must be equals to theta. Now from this relation I theta double dot, take this term mg and replace this sine theta by theta, okay, into L equals to 0. Towards one side take all the terms, okay. Now rearrange this equation in a such way that you can compare this equation with the SHM equation in this way, okay. So equation number 1 for this. So we know simple harmonic motion equation. So what's about that equation? If I consider the angular moment, okay, circular motion for any system, then the equation with us theta double dot plus omega n square into theta equals to 0, equation number 2 with us. So straightforward compare equation number 1 and equation number 2. So what we get here? Omega n square. Just compare this term, okay, and here, okay, other terms actually as it is. So omega n square equals to mgl divided by I. In this way you can get the relation, okay. Now for the concentrated mass, over length L, we know this I is nothing but ml square, okay. So from this equation number 3, if I replace I by ml square, so what we get here? Omega n square root of 1, omega n equals to square root of mgl divided by I you have to replace by ml square. So 1l get cancelled, m get cancelled. So what we get here? Omega n equals to square root of g divided by L. In this we can get the relation in terms of radian per second. Okay. So if I want this relation in terms of hertz, then I'll just erase some portion from upper side. You can get this one. Fn equals to 1 upon 2 pi square root of g divided by L in terms of hertz, like this. So next point is given here. We have to solve the same problem by using energy method. For that, we know in case of energy method, it is very important to get the potential energy as well as kinetic energy. So first of all, get the value for potential energy. For that, see the displaced diagram is drawn here. If I pull this one heavy bob towards one side, okay, so at this position, whatever the length of this bob, okay, from the center of it, okay, we know the length for this one is nothing but the L, okay. When I displace the bob and the bob reaches up to extreme position, then say this length is nothing but this one OC, okay. So from this triangle, if I give the name for this one, so before displacement of this bob, I'll just give the A name here for this position, and for this one I'll just say A dash, okay, A dash at the center of the, okay, bob. So from this triangle OC A dash, okay, so what's about the length of this side? You can get the L cos of theta, okay. So here with us L, so this height is nothing but the H. So first of all, get the potential energy. So what's about the potential energy? Potential energy is simple concept, we know, mgh, okay. So this is the relation we know. So what's about this h? H from the geometry, h is nothing but OA. So here OA total length with us, and this length with us CA. So H is nothing but the, here what we get here, CA, means here what we get, H is nothing but OA minus here total length with us OA, and next what's about this one, OC. So difference between OA and OC is nothing but the H. So what's about the OA? OA from geometry we know L. What's about the OC? OC from this geometry with us L cos of theta. Okay. So what's about the H? H is nothing but OA with us L, OC with us L cos of theta, like this. So H is nothing but, just take this L as common. So H you can get in this way, L into 1 minus cos of theta. Okay. So what's about the potential energy? Potential energy with us, potential energy equals to, so what's about the potential energy? Mg, H means here L into bracket 1 minus cos of theta, like this. Now get the kinetic energy. So what's about the kinetic energy? Just by this one, mass m is nothing but 1/2 I into theta single dot square. Okay. So once we get the kinetic energy and potential energy, okay, we can easily get the value for total energy. Total energy is nothing but addition of kinetic energy and potential energy, like this 1 minus cos of theta. So can easily differentiate this, okay, to get the relation for the natural frequency. So differentiating with respect to time t and equating to 0. Okay. So as per conservation of energy, okay, this must be equals to constant. Okay. So differentiate this one with respect to time t. Now focus here. You have to differentiate this left side term du by dt equals to, you have to take the differentiation of this term. I will remain as it is. What's about the derivative of this term? The 2 will come here. Theta single dot, again derivative of theta single dot is theta double dot, plus next term mg L. Okay, this term will remain as it is. The derivative of this constant term, okay, is nothing but the 0. So what's about the derivative of this term? Derivative of this one is nothing but cos theta is minus sin theta, and here minus minus becomes plus, and get the sin theta. Okay, derivative of this constant now becomes 0. Okay, so here 2 get cancelled, and in the next step 5 you can get 1 theta double dot. I'll just separate this mg. Again derivative of this one, I forget to take the derivative of this theta, is nothing but theta single dot, okay, goes to 0. Here sin theta multiplied by theta single dot equals to 0. Okay, since sin theta is very small, okay, you can get the sin theta equals to theta. So in this case, just take this theta single dot as common and write this term I theta double dot plus mgl into, replace this sin theta by theta. Already we have taken this one theta single dot at common, just equate with the 0. So in this case, the velocity of this whole system not becomes 0, means this bracket must be equals to 0, as theta naught is not equals to 0. Therefore I theta double dot plus mgl into theta must be equals to 0. Now write this equation in a such way that, just erase this portion this side. So theta double dot plus mgl divided by I into theta equals to 0. In this you can get the relation. Okay, so for the concentrated mass, already we know here I equals to ml square. Therefore, theta double dot plus mgl divided by ml square equals to 0. 1 m get cancelled, single it get cancelled. Okay, so here we get theta double dot plus g by l into theta equals to 0. Equation number 1 for this. So you have to just compare this relation with the SHM equation. We know SHM equation theta double dot plus omega n square into theta equals to 0. Equation number 2 with us. Okay. So comparing equation number 1 and equation number 2, what do we get here? Omega n square equal to square root of this one g divided by L. Further, omega n equals to square root of g divided by L in terms of radian per second. And in terms of hertz, we can get 1 upon 2 pi square root of g divided by L in terms of. Let us start with the next problem. For the system as shown in figure, find the equation of motion and also determine its natural frequency. So system is given like this. Okay. So first of all, you have to draw the free body diagram for the given system. For that, if I stretch this block to one side, then see the various forces acting on the various parts available in the given system. Okay, so first of all, here this way we'll draw the free body diagram. Okay, so in this way the position of the mass will changes from its original position to next position. So whatever the weight of this one will act in downward direction with the magnitude mg. So this angle with us theta, here we can get mg cos of theta. At the same time, this component we can get mg sine of theta. So here the spring constant of the stiffness with us k. Okay, like this. When I pull this one simple pendulum towards one side, the tendency of this spring to stretch, okay, like this one. So whatever the spring force comes inside of that spring is nothing but opposite side of the motion of this pendulum, simple pendulum. Okay, the tendency of this simple pendulum to move towards this side at the same time. So what's about this one? The restoring force offered by this spring in opposite direction. Okay, so what's about this one? I'll just consider this force is nothing but the S. So this is nothing but accelerating force. Okay, that will comes in the direction of motion of that pendulum. Okay, so the length for this one with us L, just say this is nothing but the A position. Okay, with us here A dash with us. Okay, so this distance, small distance, we'll just consider the distance as nothing but x. Okay, this distance already given in the problem, this one is nothing but A distance with us. Due to deflection, this one theta, let the spring be stretched by distance x. Okay, hence the restoring force by the spring will be, I'll just say that restoring force by the spring is nothing but k into x, and the restoring couple will be restoring force, I'll just mention here, restoring force by spring will be s equals to k into x, and the restoring couple will be k into x multiplied by a. So here you have to take the moment of this s means here spring force. Okay, moment of this spring force about this point, so this distance with us a, so this spring force can get k into x, so k into x multiplied by this distance is nothing but the restoring couple. Okay, so as theta, this angle is very small, so we can get the relation for that x and theta. Okay, from this triangle, just see the small triangle, this triangle here, the earlier it was name given a dash and o. Okay, so what's about the tan of theta? Tan of theta is nothing but front side divided by this side with us a, front side with us x. Okay, this side with us a. For the smaller angle you can just say tan of theta again equals to theta. Okay, so what do we get here? X equals to a into theta from this relation. Now we can easily apply the Newton's second law of motion. From Newton's law of motion, it is very important to develop the differential equation first of all. Okay, so by using the sign conventions, so what's about this one? This is nothing but the accelerating force. So what's about the Newton's second law of motion? Accelerating force equals to summation of external forces. First of all, concentrate on this accelerating force. Accelerating force turns about this point in anti-clockwise direction. So consider this one as positive, equals to external forces. Now concentrate on the external forces very carefully. So first force is here, okay, whose magnitude. So what's about this force? X equals to kx. Okay, so what's about this force? See the direction, the tendency of this one to turn about this point in which direction? This one in clockwise direction. So give the minus sign for this one. So what's about the, this indicate the spring force. Okay, so distance is here with a, so multiplied by a to take the moment of this force about one o point, you need to multiply by this a distance to this force ax. Okay, so what's about the next one? Mg sine of theta. You have to take the moment of this mg sine theta about this point. The tendency of this force also turn about this point in clockwise direction. So give the minus sign for this one. Mg sine of theta. This is the force, and the length for this one, or the distance with us L. Okay. Now what's about the next point? In this case, rearrange this equation so that we can compare this equation with the SHM equation. Okay, so before that, try to bring this equation in one variable. Here the sin theta is very small, so consider this sin theta is nothing but theta. Okay, so and once again we know the value for this one, x is nothing but a theta. Okay, so replace this x by a theta x by a theta. So this a will remain as it is. After just replace this x by this one a theta plus mg, this sin theta by theta into L equals to 0, like this. Okay, in this we can get the step. So what's about the next part? So once we get this equation, try to write this equation in simple form so that you can compare this equation with the SHM equation. Okay, so I theta double, this one theta double dot plus k into a theta a plus mg theta L equals to 0. I'll just write this equation in this way: theta double dot plus mg. I'll just write this mgl term first. Okay, mgl plus this one, next one k, a multiplied by a is a square. Okay, k a square divided by this I term. Okay, I'll just take this I here, then take this theta common from both the term theta. Okay, and equate with the 0. So as per our previous discussion, we know for concentrated mass, for concentrated mass I equals to ml square. You can get this one theta double dot plus mgl plus k into a square divided by ml square. Okay, into theta equals to 0, like this. So in the next step, you can easily compare this equation with the SHM equation. So we know SHM equation theta double dot plus omega n square into theta equals to 0. We equate this equation number 1 and 2. What do we get? Omega n equals to square root of mgl plus ka square divided by ml square, in this way. Okay, in terms of radian per second and in terms of the serial this question, hertz, we can get 1 upon 2 pi square root of mgl plus ka square divided by ml square in terms of hertz. So let us start with the next problem. For the system as shown in figure, find the equation of motion and also determine its natural frequency. So the system is given like this. Okay, so first of all, very important to draw the free body diagram of the given system. Okay, so I'll make the free body diagram on the same diagram. Okay, if I displace this block, the block will take a new position like this one. So weight will add in the downward direction, whose magnitude mg with us. So this component we can get mg cos of theta. This component with us mg sine of theta, like this one. If I pull this one back towards one side, okay, automatically this spring get compressed and this spring get expanded. And just draw the expanded diagram of this like this one, and the spring from this side get compressed. Just consider on the red portion. Okay, so this is nothing but the displacement of the spring takes place. Just consider this displacement is nothing but delta 1 for this spring, and for this one I'll just consider this is nothing but the delta 2. Okay, just mention that delta 2 here. This indicate the delta 2. Okay, so what's about the spring force by this spring? The direction of this one must be opposite direction of displacement, whose magnitude is the thing. But here the k stiffness for the spring with us, and the deflection with us delta 1. So the spring force will comes in the opposite direction of displacement, and in this case the spring get expanded. In this case the spring get compressed. So the tendency of this spring to restore its original shape means the spring force will come in the same direction like this one, whose magnitude is nothing but stiffness with us k and the displacement with us delta 2, k into delta 2 with us here like this one. Now from geometry, for the smaller angle you can just say delta 1. So what's about this delta 1? If you consider this triangle, small triangle, okay, so I can get the relation between this linear displacement. In short, this is nothing but the linear displacement, and this is nothing but the angular displacement, okay, in terms of theta. Okay, so get the relation between this one, linear displacement and angular displacement. For the smaller angle we can straightforward get a into theta. Okay, so this distance with us a already is shown here, this distance with us a, okay, and this distance with us b. So delta 1 we can get a into theta. Similarly delta 2 is nothing but, if we consider here this distance with us b, now consider this small triangle, this one. Okay, so what's about delta 2? Delta 2 is nothing but d into theta. Okay, in this you can get the relation. Now from Newton's second law of motion, Newton's law of motion, okay, just apply this Newton's second law of motion and get the differential equation. For that we know the Newton's second law of motion. Accelerating force equals to summation of external forces. Now see the accelerating force with us, this one I into theta double dot, that will comes in the motion of that ball, I theta double dot, okay, like this one, equals to external forces with us, this force and this force. Okay, so both the forces turns about this point in clockwise direction. So first of all just concentrate on this spring force. Okay, so k multiplied by delta 1 multiply by this distance with us, you have to take the moment of this force about this point, so a distance with us. Okay, so this turns about this point in clockwise direction, that's why the negative sign given for this one. Similarly next one, k into delta 2, the tendency of this force also turns about this point in clockwise direction, so give the minus sign for this force also. And see the distance, this distance with us given in the problem b. Okay, so this force we have considered, this force we have considered, spring force here we have considered, this one considered. So what's about this one, mg sine of theta multiplied by this one. So the tendency of this force turns about this point once again in clockwise direction, mg sine of theta multiplied by L. So what's about this force? The line of action of this force passes through this point, so we can neglect this force. Okay, because the distance becomes 0. So in this case I theta double dot. What's about the next one? And just take all the forces to us one side in this way, mg sine of theta into L equals to 0. Now simplify this. What's about this relations we get earlier for this delta 1? Already this information with us, I theta double dot plus k into delta 1 with us a into theta into a plus k into delta 2 with us b into theta. Okay, so for the this one Delta 2 is nothing but b into theta multiplied by b plus mg theta into L. Since this sine theta is very small, so we can replace this sine theta by theta, equate this term with the 0. Okay, so write this equation in modified form so that we can get, or just compare this equation with the frequency, simple harmonic motion frequency equation. So a multiplied by this one, a multiplied by a square into theta k into base square into theta plus mg into L into theta equals to 0. Okay, so I is here. I'll just write this equation in this way: k square plus kb square, okay, plus mgl divided by I into theta equals to 0. So for the concentrated mass, we know, I'll just erase this portion. Since I equals to ml square, okay, just simplify this one. Theta double dot plus ka square plus kb square plus mgl divided by ml square into theta equals to 0. Okay, so again we can just write this one in this way: k square plus kb square into k plus mgl divided by ml square, okay, equals to 0. Okay, just multiply this term by theta with the 0. So we know SHM equation. What's about the SHM equation? Theta double dot plus omega n square into theta equals to 0. Comparing equation 1 and equation number 2, what do we get? Therefore omega n square equals to, only you have to consider this term, compare this term with this one. So omega n square equals to, what do we get here? K square plus kb, sorry, this one, a square plus b square into k plus mgl divided by 1 l square term will come. Okay, or in the next step we can write like this: omega n equals to square root of a square plus b square into k plus mgl divided by ml square. Okay, so in terms of radian per second and in terms of hertz, we can get like this. I'll write this here: Fn equals to square root of n equals to 1 upon 2 pi square root of a square plus b square into k plus mgl divided by ml square in terms of hertz.